STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Chris Gunn.
Hey STEM fans, welcome to this week's episode of STEM Stars. It's a chance where we get a moment or time to reflect and see what's going on at NASA and chat with STEM professionals from all across the agency. I'm so excited to welcome our guest today. But before we get started, my name's Jen Hudgens and I'm coming to you from the Kennedy Space Center in Florida. It's a little bit rainy today, but we're going to keep that rain away. We're going to talk about something exciting. The James Webb Space Telescope. So our guest today is Chris Gunn. He is a photographer with the program and with NASA. So I'm really excited to find out what you actually do as a photographer when you work for NASA. And I want to share with you what our agenda is going to be for today. So we're going to chat with Chris. We're going to meet him, find out what his background is, his education, find out how he got started as a photographer at NASA. You'll have a chance to ask all the questions that you have in the chat box. And we're going to learn more about what your mission will be at the end of today's episode and then what's going to be on next at NASA STEM Stars. So if you have any questions along the way in today's chat, drop them in the box and we'll get those to Chris as soon as possible. So welcome, Chris. How are you doing today?
I'm doing great. Glad to be here.
So you work out at the Goddard Space Flight Center in Maryland. So hopefully your weather is a little bit better than ours today.
It's really,
do you mind
really nice.
sharing? Oh, good. I'm glad to hear that. I wish it was nice here. Ugh, it's thundering and lightning and storming outside. So tell us a little bit about yourself and what are you interested in outside of your job at NASA as a photographer?
Well, I'm Chris Gunn. I do work at NASA's Goddard Space Flight Center as a photographer. I really enjoy cycling on my off time and working on cars. My interests outside of work tend to revolve around science and science communication, just learning more and more about science of all types, especially space exploration and photographic art.
Can you talk a little bit about science communications? What does that entail?
Science communications, I guess, is what really got me involved in science to begin with. When I was a kid, I loved reading. And I loved reading books that made science digestible for me, that I could understand. And I think science communications revolves around having scientists and engineers, anybody in any science field, boil it down so that the average person can understand the science. Right? So to interest everyone from young and old. So that's science. And I'm involved. Go ahead.
Yeah, I was going to say, so it's kind of storytelling in whatever medium that you decide.
Exactly. So I'm involved in science communications because I create wonderful illustrations of the James Webb Space Telescope. That's the current project that I'm working on.
So I was going to say, is there a degree for science communications, or tell me about your path through school?
So I have a very interesting path through school. I started off in college wanting to be a lawyer. So I went to Morehouse College and I studied political science. After school, I actually started working at a law firm as a clerk and a librarian. And I found it not very interesting, to be honest. It was a wonderful organization, a wonderful law firm, and I happened to meet one of the lawyers there who was a film professor at a local university here in Washington, D.C., and I told him of my interest in photography, and I actually had a portfolio, and he took a look at it, and he said, "What are you doing here? Why don't you pursue your passion?" So I actually went back to school at the University of District of Columbia here in Washington, and I studied photography. So my degree is in photography, and I opened a studio right after that and started producing photographs for magazines and newspapers and universities and that sort of thing. And about 10 years into that career, I found out that they were offering a job at NASA Goddard Space Flight Center. And I applied for it and I took it.
So the job was actually in photography for NASA.
The job was in photography for NASA, and they were looking for someone that could produce portraits, group photographs, photographs of day-to-day life at NASA. And then I worked there for about 10 years, and then someone asked me to join the last Hubble servicing mission, where I actually photographed the work that was behind SM4, which was the last Hubble servicing mission, the mission to service the Hubble Space Telescope.
So are you telling me that you can work at NASA and not be an engineer or an astrophysicist?
Well, yes. I mean, you can be a writer, you can be a photographer, you can support the missions in all types of ways. And communications is very important at NASA. I mean, everything that we do is communicated to the world. And part of that communication is writing, imagery, that's illustrations, that's photographs. In fact, if you think about one of NASA's most famous missions, the Apollo mission to the moon, we wouldn't know anything about it if there weren't photographs, right? So photography
Exactly.
is part of NASA's mission. That's how I view it.
So we had a student ask a question, actually. Do you have a favorite photograph or testing milestone that you enjoyed photographing the most?
Well, I've been working on the James Webb Space Telescope for the last 10 years, and I could probably count to 4 or 5 images that are some of my favorites to date. And I'm actually going to show you some of those later. Well, in fact, here are some of them. Here are some of my favorites, actually. So
Okay.
the first image, if we're reading from left to right, is actually what the telescope will look like when it sits on top of a rocket. Okay, so that is the final configuration of the telescope, and this photo was made just before it was taken into testing most recently. So if you were to say a favorite photograph, that's definitely one of my favorite shots right now. The next image, the middle image, is a photograph of some work being done on the telescope on the optical portion of the telescope. So what you're seeing there is not the entire observatory, but the optical portion of the telescope, which includes the 4 instruments that make up the telescope. And that last photograph on the end is actually a testing milestone. And that was when the telescope secondary mirror was deployed. This telescope has a secondary mirror and a primary mirror. The secondary mirror was deployed, and that's the first time and only time that that mirror will be deployed here on Earth. So these are 3 of my favorite photographs right now.
You definitely make that telescope look gorgeous. I can see that the reflective surfaces of those lenses are so beautiful.
Well, the telescope is beautiful, and part of my job is to create images that are both technically accurate, and when these images get pushed out to the public for the public to see, I do want them to be striking, and I want people to look at them and then learn more about the telescope.
So before we get ahead of ourselves, Chris, I know you brought a video with you today that kind of tells a little bit about the James Webb Space Telescope, and it's a time-lapse video. So when students watch it, they'll see the satellite open and close, I believe, in the video. So can we take a look at that video, and then we'll explore some more of your photographs of the project itself?
Video. Sounds great.
Thanks. Wow. So that telescope looks ginormous. So can you relate in size for the students about how big the telescope is in comparison to Hubble, maybe?
Well, the telescope itself is made of two components. And what you saw there in the beginning of the video of the time lapse was the optical portion, the mirrors and the instruments actually coming over, right, and being joined with the sun shield and the spacecraft itself, the spacecraft bus. Then you saw the sun shield actually deploy, so open up. And that sun shield is about the size of a tennis court. Okay. The mirror itself is 6.5 meters, which makes this telescope about 100 times more powerful than the Hubble telescope itself.
Okay, so just a couple more questions, if you don't mind, from our students. They're flying in here. So, a personal question: are you a media personnel for NASA? I guess they're asking if you work for the Public Affairs Office, or are you directly connected with the Webb telescope?
So both. My job is two-pronged. I'm both a technical photographer as well as an office of communications photographer. So some of my photography is used purely for engineering purposes, and other photography goes out to the public through the Office of Communications.
Perfect. So there's another question about photography. Is there a specific way of photographing the satellites, or is it just normal photography? Do you use special cameras that we don't normally see? Or I guess that's the question they're asking.
I use normal cameras, but one of the things that I aim for in my photography is to have distortion. You see is basically what the telescope looks like. So I try to avoid really hard angles or skew everything. So I look straight at the telescope, and I want to create the most perfect pictures I can. Like this one behind me, if you can see it.
Oh, yeah. Is there a particular camera you like using? A student has asked that. So what camera do you use? I'm sure you have several, but you might have a favorite.
So I use 35 millimeter digital cameras. I also use medium format digital cameras, which makes it so that I can blow the pictures up really big.
Okay, so some of the other questions have to do with the Webb telescope in general. So why don't we take a look at some of the other photographs that you brought with you today, and maybe we might get to answer some of those questions during our discussion. So what are we looking at here?
So here you're looking at test and also locations as to where the telescope itself was tested. So that first test is showing you how they might clean some of the mirrors at some point. This technique has actually never been used to clean the mirrors, but it's a really interesting shot. They're blowing carbon dioxide snow onto a mirror, very similar to the mirrors on the telescope, and they're cleaning the surface with that. They've never used that technique on the telescope itself. The other photograph, the center photograph, is one of the locations that the telescope is tested in, and I just thought it was an amazing location. I get to photograph in really incredible spaces. This particular space is used to test the telescope, the communications of the telescope, to see how the telescope will do in space. They shoot radio waves at it, if you will, to see how the communications will be. And then that last photograph with the pink wall, that is the room where the telescope was actually, the mirrors were assembled. So that is the clean room, and that wall there are all the filters in the clean room, right? So that's how they keep the clean room so clean. Next slide. Okay. These are two great photographs. That first one there on the left is the videographers on the team, as well as myself, had an evening with the telescope, if you will, after some testing, after some successful testing, and we were able to turn the lights down and create really, really nice lighting so that you can see how beautiful that mirror is. And that image on the right is a shot of the telescope at NASA Johnson Space Center. That's inside of a test chamber. The primary mirror is deployed, the secondary mirror is deployed, and it was a 90-day test where they actually took this telescope down to the temperatures that it will see in space to make sure that everything was going to work. And I made this photograph right after the test was completed.
The students want to know, is there going to be a webcam on the telescope where they can see it working in space?
Unfortunately, not. I would love for there to be one. In fact, I would love to go and photograph it myself, but no, there won't be a webcam on it.
Well, I know like for the Perseverance rover, there was a webcam that you could tune in and see what the engineers were doing. And I don't know the answer to this question myself. Is there something like that where we can peek in and see the work that's occurring with the telescope here on Earth?
So there was for years when the telescope was here at the NASA Goddard Space Flight Center. Now the telescope is in California at Northrop Grumman for the final testing and assembly. And there are no cameras in that facility. And that's one of the reasons that I go out periodically to make photographs so that you can see the progress.
Oh, gotcha. So you are truly our storyteller. Thank you. Thanks for sharing the story.
My pleasure.
What's the purpose of the Webb telescope? Is it going to take the place of Hubble, or what is its job going to be?
Well, as you know, the Hubble telescope is still in space in low Earth orbit, and it's doing just fine. It's still creating great science. The James Webb Space Telescope is the successor to Hubble, but it works in a completely different range in terms of light. So it works in the infrared range. And what that's going to do is allow us to see further into space and back in time, if you will. So we'll be able to see some of the first light from some of the first galaxies that Hubble was not able to see.
Amazing. That's so amazing. I can't wait to get that into space. Are you going to be at the launch, or where are you going to be during the launch of the Webb telescope?
I plan on being in French Guiana for the launch. It's launching from French Guiana in South America on Halloween 2021.
All right. That'll be a good trip, and I'm sure you'll be very proud to see that finally lift off. All right, I know
Definitely.
you brought some more photos because that's what you do. So let's look at some more of your pictures that you brought of the telescope. What are we looking at here?
On the left there, that is the solar array, which is going to, or that's 4 of the 5 panels of the solar array that's going to provide power for the telescope during the mission. That really interesting picture in the center there is the telescope when it was here at Goddard Space Flight Center during a nighttime contamination control peak at the telescope. They turn all the lights off and they look at the telescope, every inch of the telescope with lights, with flashlights. So this particular image is a time exposure. The camera shutter was open for about 2 minutes, and that's why all the people are blurry and the light seems really eerie. The image there, the last image with the 5 guys in the white suits against the white background, they're actually closing the doors to the telescope's transportation container. And that's one of my favorite pictures. It just shows that a lot of people are doing a lot of different things in the project, and it's really interesting.
Love it. I think there's another slide of some more images of Webb.
Yep.
Yeah. Well, oh, there we go.
So this is an illustration, I think, of the many faces of Webb, if you will. So I'm actually going to start from right to left describing these. So that image on the right with the 2 gentlemen standing in front of the huge primary mirror was done just before a big optical test that they were going to do. And that is the entire 6.5 meter mirror, primary mirror of the telescope in its full glory. And that gives you an idea of the size of that mirror compared to those 2 guys on the floor there. The image in the center shows how the telescope is folded for launch, right? So one of the wings is folded back. So you have, we call those wings, and then there's a center section. So you have the 6.5 meter mirror with one of the wings with the 3 mirrors on the side folded back as they're doing another test there. And that final image there on the left is actually the image of the telescope folded for launch with the sun shields partially folded. So that gives you an idea of the different parts of the telescope, as well as how it relates to the size of those technicians down there at the bottom.
The students are asking, are the mirrors made of actual gold?
The mirrors have a layer of gold on them. So the mirrors themselves are made out of beryllium. They chose beryllium because it's very stable at the temperatures that the telescope is going to see. But the mirrors have a layer of gold. In fact, if hopefully I get this fact right, but all the gold on the mirrors, all the gold on all 18 of the mirrors is about the same, I guess, weight as a golf ball. So it's not that much gold, but it is actual gold on the top of the mirrors. Yes.
What's the benefits of using gold?
Gold happens to reflect infrared light better than just about anything else. So it's used for its optical properties. Yeah.
Very good. The students are asking, and maybe we can show the next slide because it kind of shows what your life is like at NASA. Are you going to be assigned to a new project once Webb launches?
I hope to work as a photographer on the Nancy Grace Roman telescope. That is it's a wide field infrared telescope, and it is slated to begin construction now, actually, at the Goddard Space Flight Center. Yeah, so that's what I wear when I not the shot of me with the hair flying, but the shot of me with the camera in my hands. I actually wear a clean suit whenever I go into the clean room, just like the technicians. I have to wear the clean suit. I have to wear the mask, the gloves, the booties, everything. And my cameras have to be clean before I actually go into a clean room. Now that shot of me on the right there is me during a zero-G flight. We worked a really brief project, but that project flew in a zero-G camera, and one of the guys was nice enough to take this picture of me, and it was a lot of fun.
Oh, I bet that was a lot of fun. So that's an airplane that you can take a flight, and it does parabola flights, and you occasionally gain weightlessness, just like an astronaut. So I can imagine that felt amazing.
Yes, it was a really amazing feeling.
Yeah, don't forget about putting those questions in the chat box. You guys are doing a great job so far. We've gotten some really good questions for Chris. So let's see, I can ask you some more while we've got a pause here. What orbit will the James Webb Telescope attain?
The James Webb Space Telescope is not going to orbit Earth. It's actually going to orbit the sun, just like we do. It's going out 1 million miles from Earth, and it's going out so far so that the radiation, the heat, the light from Earth will not affect the telescope itself. So that particular orbit is called L2, the Lagrange point 2, or L2.
Someone's addressing your wearing the bunny suit there. So why is such great levels of cleanliness needed for making and transportation of the telescope? So why the bunny suit? Are you protecting yourself? Or are you protecting the telescope?
We're protecting the telescope. We don't want any dust, any hair, any fibers from our clothes to actually interfere with the operation of the telescope when it's in space.
Very good. Why is the telescope so long?
So long. So big?
So I think when it deploys, you see that long, that long bit that comes out in front of the big mirror. So yeah, why is it so long?
So the largest part of the telescope is the sun shield. And it is what it sounds like. It's a shield from the sun. So just like you might have an umbrella to shade you on sunny days, we need to keep the telescope cool and in the shade. So that sun shield blocks the telescope's instruments from the sun, because this telescope needs to operate really, really cold.
Very good. Okay. So will there ever be a possibility to repair the telescope if there is an issue?
Well, I think that we won't have any issues. I think that's the hope. And I'll never say never, because I'm not an engineer and I've always been amazed, but there are no plans to repair this telescope.
Okay. Oh, goodness. Do you know how much money this telescope costs? That's a big question.
I've heard it's a lot.
So I've heard a lot too. Let's look at some. You did bring some larger pictures that I want to share with the students before we run out of time. So there's one of someone, it looks like they're being reflected in the mirror. Can you explain this photo to us?
So the mirrors were made in the United States by a company, and that company sent the mirrors to us basically one by one. So this was actually the first mirror to arrive at the Goddard Space Flight Center, and they're inspecting it. They're looking it over inch by inch to see if there are any imperfections, if there's any contamination, because that's what we need to do in order to make sure that this telescope is perfect. So this was the first mirror to arrive.
Perfect. Let's look at the next one that you brought. Is Webb the only project you've worked on for NASA while we're waiting for the next photo?
I worked on Hubble.
Oh, Hubble.
On the last
okay.
Hubble surface.
I had a student asked if you had taken a picture of Orion for the Artemis program, so you haven't had a chance to go and do that yet.
No, I haven't. So
okay,
so
this is my favorite picture.
It's one of my favorites too. This is an engineer. His name's Ed, and Ed is at the bottom of a chamber called the Space Environment Simulator. So the environment that he's in is designed to get really, really cold. But believe it or not, there are certain parts of the telescope which need to be kept really warm. And they use special heaters on those parts. And this blanket was also designed to keep some of those parts a little warmer than their super cold parts. So he's getting that blanket in place. It's called a thermal blanket. And I just had to make this photograph because it just looks really neat.
I've actually seen those thermal blankets used in like emergency preparedness kits. Are those similar to what you're using there at NASA?
It's very similar. Very similar.
Yeah.
Yes.
It's like a tinfoil blanket. Interesting.
Right. It's lightweight, but
yeah.
Go ahead. No.
I think we had one more photo that you wanted to share with us before we get to the students' mission for the day.
Okay. So this is another peek inside of the inner operations. So each one of those mirrors came in its own special container. It's a container sealed environment. So the environment inside of the container is sealed, and so no contamination can get in. And I just thought it was neat how these guys had to push the mirrors around the Space Flight Center there, and I wanted you to see this shot.
So do you think Webb is going to compete for Hubble as far as the legacy of the two telescopes go, or do you think Webb is going to be a completely different story than what you told with Hubble?
I think that Webb will continue the story, and I definitely don't think that it will compete, but it will augment, it will add to the story, and it'll give us more insights into our universe. So I think we need both of them.
I agree. I agree. So in the last few minutes of our episode today, Chris, do you have any final advice or tips for our middle and high school students that may be watching?
Well, if you look at my story, I've come full circle. I had an interest in science and engineering. In fact, that's what got me into photography to begin with. And I didn't necessarily pursue my pure interest when I first went to college. I actually recommend that you look at what your interests are, look at what your passions are, and take a long look at the schools and what they might offer you, and follow your heart.
I love it. Follow your heart. That's a good way to end. So we're going to challenge students today to an activity. They've got their own mission. And what they can do is actually create their own bookmark about the life cycle of a star. There's going to be a lot of work that Webb's going to be collecting and a lot of data that we're going to learn thanks to the Webb telescope. So students can begin their journey of knowledge about the life cycle of a star by creating their own bookmark. And you can print the bookmark and the activity and the supplies that you'll need at the link, and we'll put that in our chat box for you. And be sure to share your work with us on social media by tagging us at #NextGenSTEM. And then next week, or actually I believe it's this Thursday, we have a special episode that's highlighting our green run test of the R25 engines run, and will be on October 21st, this Thursday at 2 o'clock Eastern. Make sure that you hit the subscribe button down at the bottom of your screen so that you get notifications of when those episodes will be coming up. And I just want to use this last few seconds to thank Chris for joining us today. I hope you had as much fun as I did. And I want to encourage the students to follow your heart, and we'll see you next time.
Thanks for having me.